Good day everyone! Today's episode is about thermal expansion. This is your Sir Bits at your service and welcome to Bits Academy Season 2. Consider a railroad which is usually composed of steel. And then when steel is heated, it expands and compresses when cooled. When rails are joined together without leaving any space for expansion, the rail expands causing the railroads to bend. The tendency of the matter to change shape, volume, and area in response to change in temperature is known as the thermal expansion. This tendency of expansion can be observed in solids, liquids, and as well as in gases. In solid, for example, atoms and molecules are constantly vibrating around their equilibrium point. Thermal motion is the term for this type of activity. When a substance is heated, its particles begin to move more, creating a greater space between them. The coefficient of thermal expansion of a material is defined as the degree of expansion divided by the change in temperature, and it generally varies with the temperature. Here are some coefficients of thermal expansions of a material. We have three different types of thermal expansions: the linear expansion, area expansion, and the volume expansion. But in this episode, we will focus on the linear expansion. Thermal linear expansion is when an object is heated or cooled. Its length changes by an amount proportional to the original length and the change in temperature. There are only few variables that you need to know to perform the calculation of the thermal linear expansion: the original length, the coefficient of the linear thermal expansion, the initial temperature, and the final temperature. To compute the thermal linear expansion, we will use the formula change in length is equal to coefficient of linear expansion multiplied by the initial length multiplied by the change in temperature, for change in temperature is equal to final temperature minus initial temperature. The outcome can be used to calculate the impacts of temperature on measurement uncertainty. For example, a steel is 40 cm long at 20 degrees Celsius. The coefficient of linear expansion for steel is 13.2 times 10 raised to negative 6 per degree Celsius. The increase in length and the final length when it is at 70 degrees Celsius will be, the given for this problem are the change in temperature, which is 70 degrees Celsius minus 20 degrees Celsius is equal to 50 degrees Celsius. The original length, which is 40 cm, and the coefficient of linear expansion for steel is equal to 13.2 times 10 raised to negative 6 per degree Celsius. The required for this problem are the change in length and the final length. Okay, let's solve this problem. First is the change in length. Using the formula, change in length is equal to coefficient of linear expansion multiplied by the initial length and multiplied by the change in temperature. So we have 13.2 times 10 raised to negative 6 per degree Celsius multiplied by 40 cm and multiplied by 50 degrees Celsius, which gives us 0.0264 cm. The answer for this problem is the change in length of the steel will be 0.0264 cm. Next is for the final length. Let's just add the initial length and the change in length, which is 40 cm plus 0.0264 cm, which gives us 40.0264 cm. So the final length of the steel when it is 70 degrees Celsius will be 40.0264 cm. Another example is an iron rod heated from 30 degrees Celsius to 80 degrees Celsius. The final length of the iron is 115 cm, and the coefficient of linear expansion is 11.7 times 10 raised to negative 6 per degree Celsius. What is the original length and the change in length of the iron? The given for this problem are the change in temperature, which is 80 degrees Celsius minus 30 degrees Celsius equals to 50 degrees Celsius. The final length, which is 115 cm, and the coefficient of linear expansion, which is 11.7 times 10 raised to negative 6 per degree Celsius. The required for this problem are the original length and the change in length. Okay, let's solve this problem. First is the original length. We will use the formula of the change in length for the linear expansion, which is change in length is equal to coefficient of linear expansion multiplied by the initial length multiplied by the change in temperature. And the formula of the final length, which is final length is equal to initial length plus change in length. Relating these two equations, we have final length is equal to initial length plus coefficient of linear expansion multiplied by initial length multiplied by the change in temperature. By factoring out the initial length, we have final length is equal to initial length multiplied by the quantity 1 plus coefficient of linear expansion multiplied by the change in temperature. And then by cross multiplication, we have final length divided by 1 plus change in temperature multiplied by the coefficient of the linear expansion is equal to initial length. So we have the formula initial length is equal to final length divided by 1 plus coefficient of linear expansion multiplied by the change in temperature. Then let's substitute the given. We have 115 centimeter divided by 1 plus the quantity 11.7 times 10 raised to negative 6 per degree Celsius multiplied by 50 degrees Celsius. Then we have 115 centimeter divided by 1 plus 585 times 10 raised to negative 6 is equal to 115 centimeter divided by 1.000585 is equal to 114.93 centimeter. So the final answer is the original length of the iron rod is 114.93 centimeter. For the change in length, we will use the formula change in length is equal to final length minus initial length. So change in length is equal to 115 centimeter minus 114.93 centimeter, which gives us 0.07 centimeter. So the change in length of the iron rod is 0.07 centimeter. And now we already know what are the types of the thermal expansion and how to calculate them, specifically the thermal linear expansion. Once again, this is your servants at your service, Classes Gist.